Once the chips are manufactured in Arizona, they need to be shipped to Taiwan for packaging. The wafers must be physically transported, packaged there, and then sent back to the United States. Will having TSMC engineers join Intel really solve this issue? This is something that people who really don't know about technology are saying. Hello everyone, this is Error. According to Wall Street analysts' speculations, there's now a rumor that the US government is planning to establish a joint chip production company with Intel and TSMC, which is bringing Intel back into the spotlight. This week in Paris, the vice president, in light of J.D. Vance's statements, the Trump administration is working to merge Intel and TSMC in an effort to bolster the production of American semiconductors. The media has been asking Intel and TSMC for comments to verify the truth of the matter, but both companies have chosen not to respond. If they do end up working together, what exactly will they produce? And is it practical and worthwhile to pursue this collaboration? We need to delve into this from a technological standpoint, so let's examine it closely. Here, we have a comment related to Intel. The memo specifically mentions that TSMC plans to dispatch their engineers to Intel's 3nm and 2nm production lines to impart their expertise. This indicates that TSMC is actively contributing to this collaboration, rather than being a mere observer. This new entity will be jointly owned by TSMC and Intel, and it will be operated by TSMC. We believe this is quite a remarkable and almost magical development. Wouldn't you agree? Last week, Intel's stock price reportedly rose by 20 to 30%. However, these are still just rumors and haven't been confirmed. While it might take a long time to execute the project, it is thought to make sense. TSMC is planning to use EUV lithography for their 3nm and 2nm processes. It seems there's an intention to transfer this expertise to Intel for large-scale production. This isn't just speculation from one source. Even the Financial Times has reported on it. TSMC is establishing a presence in Phoenix, Arizona, which is very close to Intel's facilities. I'll show you this on Google Earth later, but it indicates ongoing developments. There are also frequent discussions about the possibility of a military conflict between TSMC and China, given their adversarial positions. There are speculations that China might take action against Taiwan by 2027. Some reports suggest that Xi Jinping might need to stage an event around that year to maintain his grip on power. China is making significant investments in building advanced naval ships, weaponry, and artificial intelligence, showcasing its dedication to enhancing its military strength. In contrast, the United States is strengthening its alliances with nations such as South Korea, Japan, Taiwan, and the Philippines to strategically counteract China's influence. During that era, the Soviet Union was also being countered, leading to US involvement. Without delving into too many details on this engineering channel, it's been quite some time since then. Nowadays, TSMC is seen as a national asset in Taiwan. TSMC not only plays a vital role in safeguarding Taiwan, but Taiwan also remains significantly reliant on China. This is an economic situation, with 90% of the trade coming from China to Taiwan and 88% going back, so it's almost 90% back and forth. From China's perspective, they are economically restraining Taiwan, while TSMC is becoming a technological shield that can protect its economic interests. Not only economically, but also technologically and militarily, alliances might be necessary. Currently, most of TSMC's fabs are located in Taiwan. However, with Trump pushing for reshoring, and even before him, Biden has been advocating for bringing manufacturing facilities back to the US, which were previously outsourced to East Asia due to cheaper labor costs. The US is pushing for reshoring, urging TSMC and Samsung to build their facilities within the country. Recently, on February 1st, the White House announced new tariffs on Canada, Mexico, and China. There are even talks about imposing up to 100% tariffs on TSMC. This move marks a shift towards protectionism rather than free trade. TSMC, a company that holds technological supremacy, finds itself in a position where it must accommodate the demands of the US government. Consequently, this situation involves not only TSMC's fab in Arizona, which is already producing at the advanced 5nm and 3nm nodes, but also implicates Intel. From the perspective of the US government, they might be thinking, Intel isn't performing well, so who can help revive it? The US government is working on boosting its own manufacturing capabilities by putting pressure on TSMC to transfer some of its technological know-how. This move is part of a broader strategy to create a silicon shield to counter China's growing influence. Nonetheless, in the event of a conflict, Taiwan would be highly vulnerable without crucial US support. This will cause huge losses. Didn't we mention the defense industry earlier? In Taiwan, TSMC is almost synonymous with the nation itself. However, if a joint venture with Intel is established, there are significant concerns that TSMC's leading-edge foundry technology might be leaked, potentially compromising the critical silicon shield that plays a pivotal role in the global semiconductor industry. There are fabs here, but let's assume a war starts. Production of the world's most advanced 3D chips will stop immediately. Last month, an earthquake affected over 20,000 TSMC wafers. I even saw a report mentioning 50,000 wafers. This earthquake happened in the Hainan region. If you check Google Earth, here is the Earth, and here is TSMC. Let's locate TSMC. Ah, here it is, in Taiwan. Now, if we take a closer look at Taiwan, we can see Hsinchu situated in the northern region. The Hsinchu Science Park hosts numerous fabs, which can be easily found with a simple search. If you search for TSMC Fab 12, you'll find a lot of information here, including TSMC, FAB 12, P6, P4, and P8 within the Hsinchu Science Park. There's also the TSMC Museum of Innovation, and many collaborations with nearby universities, leading to significant involvement in the industry. Regarding Pepsi, it operates a 200mm wafer fabrication facility, primarily dealing with very old manufacturing processes. The recent earthquake did not occur in Hsinchu, but rather further south in Tainan, as indicated here. An earthquake occurred in Tainan, where some of the latest semiconductor fabs are situated, you know? For example, take a look at Fab 18. You can see its vast scale right here. Not only do we have Fab 18, but also Fab 14 and Fab 15 situated nearby. In Korea, we similarly have multiple fabs clustered together. Fabs 14 and 15, each boasting a capacity of 300 megawatts, are currently leading in technological advancements. Compared to the older processes like 16nm, 10nm, and 28nm FinFET processes, which were mainly used for older chips, this fab, in the case of PEP 48, is now said to produce 7nm, 5nm, and even 3nm chips. Furthermore, it is expected to handle 2nm in the future, making TSMC the fastest in this regard. Given that the manufacturing processes are predominantly carried out within Taiwan, it is highly probable that the most recent advancements and innovations will be developed right here. Let's delve into this further. Here is how it appears. If you're bored, have a look at this. It seems everyone is working hard. Are you all smoking? Anyway, the delivery has arrived, and the environment here is quite similar to our country. For instance, if you look at Hynix in our country, you will notice that the fabs are all concentrated in areas like Bundang and Icheon. From Taiwan's perspective, these facilities are concentrated in cities like Hsinchu and Tainan. When we talk about advanced packaging, which I have often explained, it is important to note that in the process of manufacturing NVIDIA GPUs, SK Hynix provides HBM to initially assemble the NVIDIA GPU. However, it is crucial to connect the cores properly. These advanced packaging facilities are only in Taiwan. They are not in the United States. Now let's compare Taiwan's location to the US. The US is really far away, isn't it? It's right here. For example, Intel's Kotlo campus, which is known for producing the latest technology, is located here. Do you know where this is? This is the famous Arizona. There are a lot of fabs here in Arizona. Currently, there are 6 fabs in operation. Fab 12, Fab 20, Fab 30, Fab 40, Fab 50, and Fab 60. Intel plans to roll out Intel 10, Intel 7, Intel 4, Intel 3, Intel 8, and a 20 at this site. Furthermore, if you look above, you will see TSMC's facilities as well. The TSMC Arizona Corporation is located in the northern part of Phoenix. Now, with the physical proximity of Arizona's F21 facility, we are not only able to manufacture Intel's 18 angstrom wafers, but we can also set up advanced packaging facilities like CoWoS, which can significantly reduce the time spent on transporting materials back and forth. In the past, for instance, if Intel wanted to make use of CoWoS. In this situation, once a fab is set up, whether it's here or in Arizona, the chips produced in Arizona would need to be transported all the way to Taiwan for packaging. After that, they would have to be shipped back to the US again. This entire process is incredibly inefficient. Therefore, it might make more sense for TSMC to build a fab here to enhance efficiency. TSMC's primary concern is that they are already leading in this field, so it feels like a huge loss to simply give away their expertise. However, with the strong stance from Trump, they are being cautious and seem to be negotiating. Therefore, if TSMC decides to build a packaging plant in the US, it could be considered a strategic and advantageous move. There is a possibility that TSMC might enter into a joint venture to invest in Intel's manufacturing operations. Intel is particularly strong in the packaging sector, often referred to under the brand name Foveros. From 2025, they will be working on things like the 18 angstrom process and the next version of the 3nm process. When considering investments in TSMC, it might be more advantageous to focus on advanced packaging, especially because Intel is handling the packaging orders from TSMC's American customers. In my opinion, investing in packaging rather than just focusing on EUV processes for 3nm and 2nm technology could yield better results. The wafers need to go back to TSMC's home country, Taiwan, for packaging, but Intel is going to handle that role? In reality, there's been considerable talk about expanding core capacity through assert companies or other post-processing partners. Given this context, it seems quite feasible for Intel to establish a joint venture. By doing so, they aim to enhance the efficiency of production lines, which, from a procedural perspective, appears to be a highly advantageous strategy. From a management perspective, which I don't know much about, it makes sense in terms of operational and financial efficiency. However, from a technical standpoint, there are many aspects that don't make sense. If TSMC were to share its expertise, it would involve supporting Intel 3 or Intel 18 angstrom and adjusting equipment with TSMC's input. There are discussions about sharing expertise, but the 18 angstrom process is set to be released this year and is already close to completion. Thus, even with TSMC's involvement midway, Intel's unique semiconductor processes, which I frequently describe, vary significantly between companies. This suggests that optimizing the process, or Intel's, when wafers were produced, the data collected by TSMC and Intel was very different. So, process management and optimization had to rely on that data. Simply adding TSMC engineers to Intel wouldn't automatically improve things. This is said by people who really do not understand the technology. Also, TSMC engineers are likely not familiar with Intel's UB-based manufacturing processes. What this means is, even if they have EOB, it's not the same EOB. For example, Intel is already mass producing at 3 nanometers and will start mass production at 18 angstroms in a few months. Based on what has been stated, for something like the 18A process, no additional recipe or process modifications are necessary. They are already in coordination with ASML to align various process conditions. So what could TSMC engineers possibly add to this? When examining the semiconductor manufacturing process, it starts with steps like wet polishing, and then, when you apply photoresist, expose it to light, and then etch it. All sorts of chemicals and materials come into play. These supplies and equipment companies, often referred to as subcontractors or equipment manufacturers, differ between TSMC and Intel. Even if they use the same chemicals, the purity levels and the methods they employ will differ, meaning that the recipes they use will also vary. The US government is eager to fast-track this process. Given TSMC's success, they might encourage them, saying, "Go ahead and give it a shot." However, when examining this process, it seems more like a hopeful idea to set up a joint venture without a thorough understanding of the technology involved. Personally, I think it's more of a wishful thinking. You need to control the temperature, gas flow, and photomask. All these elements are different, and just adding TSMC's engine won't necessarily bring improvements. Additionally, regarding EUV equipment, Intel has already fine-tuned its use for cutting-edge processes. It's important to note that while Intel is capable of utilizing EUV technology, the challenge lies in adapting the process design to meet Intel's specific requirements. Meanwhile, Morris Chang, the founder of TSMC, often emphasizes that within the rigorous and hierarchical culture of East Asian companies like TSMC, each firm possesses its own distinct manufacturing philosophy and technological culture. He is quite doubtful about whether merely swapping personnel can result in effective collaboration in such an environment. If they build the packaging plant, I think it would be quite good. From TSMC's perspective, it's not too bad either. However, Taiwanese media are quite anxious about the Silicon Shield. But considering the current situation with tariff pressures and Trump saying things like, "We're protecting you, but you're not doing anything for us," and threatening to raise tariffs up to 100%, building this packaging fab is a significant move. Establishing these advanced infrastructures or cores in the Intel Phoenix area is highly beneficial due to the close physical proximity, which greatly enhances efficiency. This, in turn, could lead to stronger partnerships with American clients. Alternatively, if Intel oversees these operations, it's crucial to differentiate that the 3 nanometer and 2 nanometer EUV processes belong to the front-end manufacturing stage. Initially, the plan is for TSMC engineers to come in and assist with wafer production, which aligns with the US government's wishes. However, considering the current stringent post-processing conditions, if TSMC sets up these facilities in the US and works together with Intel, there could be some significant benefits for TSMC as well. The design and all these processes take more than 2 to 3 years, and now that Chipalong Strong is set to be released this year, suddenly saying they will send EUV engineers to TSMC is something that policymakers or those defending the US government might push for, because they might not fully understand the process. They can't know all the technology, but it's too... So, considering only the financial aspects or efficiency, and the pressure from tariffs, there are some technical mismatches in my personal opinion. Therefore, instead of sending engineers to the lithography, EUV side, if there is some collaboration in the advanced packaging area. From TSMC's perspective, there might be ways to circumvent some tariffs, so I quickly summarize today's key points for you. Please visit Unreal Tech, our international channel, where you'll find plenty of content in English. We also share quick and interesting updates on Instagram, so follow us there to stay informed. This has been Error. Thank you for your attention.